Now we begin with a new chapter, that is green chemistry and nanochemistry. Chemistry plays an important role to improve the quality of our life. There is a lot of development in the field of science and technology which has made our life more easier. However, this development is unfortunately a threat to human health and environment. We are facing problems like energy crisis and environmental pollution due to increase in human population and industrial revolution. If we want to minimize these problems of environmental pollution and energy crisis, then we have to adopt green chemistry. The aim of green chemistry is to maximize efficiency and minimize hazardous effects on human health and environment. The term green chemistry was coined by Paul T. Anastas. How would you define green chemistry? Green chemistry is the use of chemistry for pollution prevention by environmentally conscious design of chemical products and processes that reduce or eliminate the use or generation of hazardous substance, which means you need to reduce the environmental pollution by using substances which are free of hazardous compounds. So if we want to reduce the impact of energy crisis and pollution, then we have to adopt the 12 principles of green chemistry which are put forward by Paul Anastas. Before moving on to study the 12 principles of green chemistry, we need to know what is sustainable development. Green chemistry plays a very important role in sustainable development, which means we can achieve sustainable development only if we adopt the 12 principles of green chemistry. What is sustainable development? Sustainable development is the development which meets the needs of the present without compromising the ability of future generations to meet their own needs. An example of sustainable development would be using recycle and renewable resources whenever possible. So this will actually save the resources for the future generation as well. Let us now study the 12 principles of green chemistry. First principle is prevention of wastes or byproducts. This principle gives priority to prevention of waste rather than cleaning and treating waste after it has been created. Let us study some examples to understand the same. In order to develop the ZWT, that is zero waste technology, waste products should be zero or minimum. ZWT also aims to use the waste product of one system as raw material of another system. Like the bottom ash of thermal power station can be used as raw material for brick and cement industry. Also, the effluents which come out from the cleansing of the machinery parts can be used as coolant water in thermal power station. In both the examples, we saw that the waste material of one system is used as a raw material for another system. Second principle is atom economy. Atom economy is the measure of amount of atoms from the starting materials that are present in the useful products at the end of a chemical process. So basically, atom economy gives us the information about number of atoms which were present as the starting material, that is in the form of reactants, and the number of atoms produced in the product. When would you say that you have attained a good atom economy? When most of the number of atoms used in the reactants are present in the products and only small amount of unwanted byproducts are formed, resulting in lesser problems of waste disposal. Let us consider an illustration to understand atom economy. The concept of atom economy gives us information about the number of unwanted products produced in a particular chemical reaction. Hence, you can calculate the percentage atom economy by the formula Percent atom economy is equal to formula weight of the desired product divided by sum of formula weights of all the reactants used in the reaction. Let us consider the conversion of butane 1-ol to 1-bromobutane. So we take butane 1-ol and treat it with sodium bromide along with sulfuric acid, which results in formation of 1-bromobutane along with sodium bisulfate and water. To calculate the percent atom economy, we have to take the mass of the desired product, which is 1-bromobutane. Sodium bisulfate and water which is formed are the unwanted byproducts. So we will be considering the mass of 1-bromobutane. Hence we have 4 carbon atoms, 9 hydrogen atoms and 1 bromine atom divided by the mass of formula weights of all the reactants in the reaction. So here we have mass of 4 carbon, 12 hydrogen, 5 oxygen, 1 bromine, 1 sodium and 1 sulfur atom, and then we will multiply this by 100. After substituting their atomic masses, we get the answer as 137U divided by 275U. U stands for unified mass. Multiply by 100 and hence the answer is 49.81%. So the atom economy percent of conversion of butane 1-ol to 1-bromobutane is 49.81%. Third principle is less hazardous chemical synthesis. When chemical reactions are designed and the synthesis route, that is in the way which they are prepared, should be as safe as possible, so that we can avoid the formation of hazardous waste from these chemical processes. You must be very much familiar with DDT. DDT stands for dichlorodiphenyl trichloroethane. It was used as an insecticide. It was very much effective in controlling disease like typhoid and mosquitoes causing malaria. However, it was realized that DDT was very harmful to living beings and hence it was banned. So nowadays BHC, that is benzene hexachloride, is used as an insecticide. BHC is prepared from gamma isomer called gamexane or lindane. Fourth principle is designing safer chemicals. This principle is very much similar to the previous principle. According to this principle, we need to produce products which are less toxic or by using less toxic raw material. We know that in chemical industries, workers are very much exposed to the toxic environment. Toxic means poisonous environment. So in order to prevent these workers from exposure to toxicity, we should think of designing some safer chemicals. Let us understand this with the help of an example. Adipic acid is widely used in polymer industry. Benzene is used as the starting material for the preparation of adipic acid. However, benzene is carcinogenic and also a volatile compound which results in pollution of air. Carcinogenic means it can cause cancer. Volatile compound means it can catch fire easily. However, in green technology, Drath and Frost enzymatically prepared adipic acid using glucose, which means they prepared adipic acid by using enzymes on glucose, which was on a safer side when compared with toxicity. Now, we move on to the fifth principle, that is use of safer solvents and auxiliaries. Chemical auxiliaries means separating agents, solvent, dispersing agents that are used in a chemical reaction. We need to choose a safer solvent for a particular step of reaction. So if we minimize the total amount of solvent and chemical auxiliaries used in a chemical reaction, then it can reduce a large amount of waste created by it. The main aim behind this principle is the use of green solvents, which are environment friendly. There are a number of organic halogenated solvents like chloroform, carbon tetrachloride, dichloromethane, etc. which are volatile in nature. Hence, we can substitute these solvents by water and supercritical carbon dioxide. We know that when we mix a solvent along with a solute, it dissolves the solute and forms a solution. Dichloromethane is a hazardous solvent, whereas water is a safest solvent. Use of toxic solvents affect millions of workers every year. A number of times, solvents are used in high amounts and some are organic volatile compounds. And the use of these solvents create air pollution, a large amount of waste and also health problems. In order to improve a process or product, the best way is to find a safer and more efficient alternative or to remove solvents altogether. Sixth principle is design for energy efficiency. Chemical synthesis should be designed in such a way that it reduces the amount of energy used. A way to reduce the use of energy is to carry out the chemical reactions at room temperature and pressure. This can be achieved by proper use of catalyst, by use of microorganisms for carrying out the synthesis of organic substances, and also use of renewable materials. Some examples of energy efficiency would be use of biocatalyst, which can work at ambient condition. Biocatalyst is the use of living systems or their part to speed up a chemical reaction. Ambient conditions include temperature, pressure, humidity, etc. Second example would be refluxing condition, which requires minimum energy. Refluxing means heating a chemical reaction for a particular amount of time while continuously cooling the vapors into liquid using a condenser. Another example is use of microwave heating. Seventh principle is use of renewable feedstocks. The perspective of this principle is towards petrochemicals. Petrochemicals are chemical products obtained from petroleum by refining. Hence, we need to make use of chemicals which are made from renewable sources like based on plants rather than crude oil. Let us understand this principle with the help of an example. Overexploitation of non-renewable feedstock will result in depletion of resources and the future generation will be deprived of it. Non-renewable is a natural resource which cannot be easily replaced by a natural means. Some examples of non-renewable feedstock are natural gas, petroleum, etc. Moreover, the use of these non-renewable resources also puts a burden on the. On the other hand, the use of renewable resources like agricultural or biological product ensures sharing of resources with the future generation. Also, it does not put any burden on the environment because these products and their wastes are generally biodegradable. Biodegradable means it can be taken back into the naturally and does not cause harm to the environment. Hence, we need to use the non-renewable resources wisely. Now, we move on to the eighth principle, that is reduced derivatives or minimization of steps. A commonly used technique in organic synthesis is protecting or blocking groups. So unnecessary derivatization is carried out, which should be reduced or removed if possible, because such steps require additional reagents and it can generate a lot of waste. Let us understand this principle with the help of an example. When we carry out organic synthesis, we very much try to protect some functional groups, and again we need to carry out its deprotection. Let us understand by studying the following example. It is the synthesis of M-hydroxybenzoic acid from M-hydroxybenzaldehyde. So here is the reaction. So here we take the M-hydroxybenzaldehyde and treat it with benzyl chloride, and here we need to protect the OH group. The benzyl chloride group attacks the O with the elimination of HCl molecule. Then we react this product with nascent oxygen to form an acid group COOH. Again, we need to deprotect the OH group, which results in the formation of M-hydroxybenzoic acid. In such a case, the atom economy is going to be less. Also, according to green chemistry, unnecessary steps need to be avoided because it results in generation of waste. Ninth principle is use of catalysis. We know that catalyst is used in a chemical reaction to speed up the rate of reaction. The advantage of using a catalyst in a chemical reaction is it increases selectivity, minimizes waste, reduces the time taken by a chemical reaction for its completion, and even energy demands. Here is a chart which includes a number of reactions, and we need to mention the catalyst used to carry out that particular reaction. First is hydrogenation of oil, and the catalyst used is nickel. Second is Haber's process for manufacture of ammonia. The catalyst used is iron. In the manufacture of HDPE polymer, catalyst called Ziegler-Natta is used. In the manufacture of sulfuric acid in contact process, platinum is used as a catalyst. For the synthesis of gasoline, metals are used as catalyst. The 10th principle is design for degradation. This principle aims at designing chemicals which degrade and can be eradicated easily. Degradation and their products should not be toxic, bioaccumulative, and environmentally persistent. The importance of this principle is that the waste should degrade automatically to clean the environment. So, taking this into account, biodegradable polymers and pesticides are preferred. Here is a chart which gives us information regarding the different types of plastic materials that we use for household chores. Currently their status, and if you recycle them, then what products you can prepare. First is PETE or PET. The name is polyethylene terephthalate, and it is used in microwavable food trays, salad dressing, soft drinks, water, and beer bottles. The current status is it is hard to clean, it absorbs bacteria and flavors, and it avoids reusing. You can recycle this plastic to make carpets, furniture, new containers, polar fleece, etc. Polar fleece is a soft insulating fabric made from polyester. Second is HDPE, that is high density polythene. It is used in household cleaner and shampoo bottles. It transmits no chemicals into food. And if you recycle HDPE, you can get detergent bottles, fencing, floor tiles, pens, etc. Third plastic is V or PVC, that is vinyl. It is used in cooking oil bottles, clear food packaging, and mouthwash bottles. Its status is believed to contain phthalates and it interferes with hormonal development, so we need to avoid it. If you recycle PVC, it can form cables, mud flaps, panclean, roadway gutters, etc. Fourth is LDPE, that is low density polyethylene. It is used in bread and shopping bags, carpet, clothing, furniture, etc. Status: it transmits no known chemicals into food. And if you recycle LDP, it forms envelopes, floor tiles, lumber, trash can liners. Next is PP, that is polypropylene. It is used in the preparation of ketchup bottles, medicine and syrup bottles, and drinking straws. Status: same as LDPE, that is it transmits no known chemicals into food. If you recycle PP, it will help you form battery cables, brooms, ice scrapers, rakes, etc. Next is PS, that is polystyrene. It is used in disposal cups and plates, egg cartons, takeout containers, etc. Status: it is believed to leach styrene, a possible human carcinogen into food. So we need to avoid it because it is cancerous. If you recycle polystyrene, it forms foam packaging, insulation, light switch plates, rulers, etc. Next is any other miscellaneous plastic. It is used in 3 to 5 gallon water jugs, nylon, some food containers, etc. It contains bisphenol A, which has been linked to heart disease and obesity. So again, we need to avoid the use of these plastics. If you recycle it, it can form custom-made products. So this was all about the household plastics that we use. Now we move on to the 11th principle, that is real-time analysis, pollution prevention. This principle says that analytical method needs to be developed in order to monitor and control prior the formation of hazardous substance. So the analytical methodologies should be developed or modified which will enable continuous monitoring of the manufacturing and processing units. And this principle is very important for chemical industries and nuclear reactors. Now we move on to the last principle, that is safer chemistry for accident prevention. So we need to develop chemical processes which are safer and can minimize accidents. When carrying out a chemical reaction, the substance should be selected in such a way that it can minimize the occurrence of chemical accidents, explosions, fire and emission. For example, if the chemical reaction involves the use of gases, then the possibility of accidents like explosion is much higher when compared to non-volatile liquid and the use of solid substance. So these were the 12 principles of green chemistry put forward by Paul Anastas. What is the role of green chemistry? The approach of green chemistry is it knows, or we know, that our earth has the capacity to deal with a certain amount of waste, but when we human beings exceed the production of waste beyond limits, then it becomes problematic and we become unsustainable. Green chemistry also helps to promote innovative chemical technologies which reduce or minimize the use of generation of hazardous substance in the design, manufacture and use of chemical products. It also helps in prevention of pollution by incorporating pollution prevention practices in the manufacture of chemicals. So basically, green chemistry is a new way, the way we look at chemicals and its manufacturing process so that it has minimum negative effects on environment. Green chemistry also helps to protect the ozone present in the stratosphere, which is very much essential for the survival of living beings. It is also helpful to control the greenhouse effect, that is global warming. So right now, the green chemistry revolution is beginning and it is an exciting challenge for chemists involved in the manufacturing and use of chemical products. So by incorporating the 12 principles of green chemistry, we should save our environment and earth. So this was all about green chemistry. In next video, we will be learning about nanochemistry.